Okay, now we cover chapter 16.2. 16.2, before that we recap 16.1. 16.1 that we learned to find a turning point, we let the first differential be equals to 0. Okay, we also learned that if we use the second differential, okay, and the value is lesser than 0, what we have is a maximum point. And if the second differential is greater than 0, what we have is a minimum point. Okay, with this in mind, we can actually start with 16.2 already, where we will learn how to apply maxima and minima to problems in real life. So I just give you one single example for this chapter, which is question 9. Okay, question 9. First, they will ask us to find they give us the volume of the box. Okay, volume is equals to 36. Alright, then they say that express h in terms of x, so we get length times breadth times height is equals to 36. So if you simplify everything, 2x squared h equals to 36. So since they want h to be the subject of the formula, h is equals to 18 over x squared. And that is the first part of it. Now we want to find the area, okay, the total external surface area of the box. So first, we will say area is equals to, okay, 2x times x plus 2 times x times h plus 2 times 2x times h. Alright, then we simplify everything, we get 2x squared plus 2xh plus 4xh. So we simplify this, we get 2x squared plus 6xh. Basically, for a rectangular box, there will be 6 different sides. So this one will give us all 6 different sides. Okay, then now, okay, what we get here is this. Okay, we let h equals to 18 over x squared. So we get 2x squared plus 6x times 18 over x squared. So in the end we get 2x squared plus 108 over x. And we have shown what the book wants us to show. Okay, notice that this has 2 surfaces, this has 2 surfaces. This one I only calculated once because they say that it's an open rectangular box. Okay, that's why this one is only 1. Usually for a box we should have 6 surfaces. In this case there's only 1, 2, 3, 4, 5 because it is open on one end. So I have only calculated this one time. So we have the surface area. Next thing we want is to find the turning point. Okay, because they ask us to find the value of x and of h to make the total surface area a minimum. So I start with a is 2x squared plus 108 over x. I differentiate one time. Differentiate a with respect to x. I get 4x minus 108 over x squared. I differentiate the second differential. The point of the second differential is for me to check if the point is a maximum or minimum later. So I just differentiate first. I get 4 plus 216 over x cubed. Okay, so now I already have my first differential and second differential. As we have learned in the previous chapter, in order for me to find the turning point, I will let my first differential be equals to 0. So my first differential is 4x minus 108 over x squared is equals to 0. To solve this, I multiply throughout by x squared. I get 4x cubed minus 108 is equals to 0. So I get x cubed is equals to 2 times 4, 8, 27. Cube rooting, x is equals to 3. Okay, if my x equals to 3, I know that h from above is equals to 18 over x squared. So it's 18 over 3 squared. my h value is 18 divided by 9 is equals to 2. Now we have to check, right, whether or not, right, the total surface area is a minimum or a maximum. How do we check? We use the second differential. So my second differential, as we found just now in the previous page, is equals to 4 plus 216 over x cubed. So what I do here is I let x equals to 3. So I get 4 plus 216 over 3 cubed. I find that the value of my second differential in this case is greater than 0. Greater than 0, as we have learned before, it is a minimum point. Hence, okay, for surface area to be a minimum, okay, x is equals to 3 and h is equals to 2. And that is it for the examples from 16.1.